Deal. We have a rectangular pen with an area of 135 square feet. What? We want to find the minimum perimeter we can use to create this pen with an area of 135. So what we have to do is we set the area, which is equal to length times width. We set that equal to 135. So that's length times width. So we have this pen with a length and a width, and its area is equal to 135. We're trying to figure out what is the least amount of material we can use to make that pen. So perimeter this time is going to be P, and it's going to be equal to 2L plus 2W again. And again, we want to be able to graph that. So we can't because it has three variables, so we can't graph it on a two-dimensional plane. So what we have to do is use our given information that 135 equals L times W. So let's just solve for W again. We'll divide by L on both sides. So we get W equals 135 over L. Okay, and this is good news because we can plug W in for W in perimeter. So we get perimeter equals 2 times 135 over L plus 2L. And if we want to simplify a little more, we can say perimeter equals 270 L plus 2L. Okay, now what we want to do is graph this and look for a minimum this time. So we're trying to minimize perimeter. So let me pull up that. All right, here it is. How exciting. We look at our graph and we get our answer. So notice again that I use X in Desmos instead of W, or L in this case, because Desmos registers X as the independent variable. So we're just going to stick with X. So in this case, X represents the length of the pen. So we see that the minimum perimeter is 46.476, and that happens when the length of the pen is 11.619. Now, if we made the length anything different than 11.619, the perimeter would be higher. The area would still be 135 because we've set area equal to 135, but this is the optimal perimeter that we were searching for.